but V4R2. And this is a module called the Cabinet Thermal Calculation module. Now, based on standard IEC 61439, which is for validation of the electrical panel's thermal characteristics, there's a requirement basically to work out or establish that the panel will not overheat or will not go below a certain temperature based on the power dissipation of the actual components, the surface area of the actual internals of the panel, the material that it's actually made of, and its position where it's actually situated. So this is all put down into a method which is stated in IEC 60890. So for this module, now you don't actually need to design the actual panel, but if we go back into one of the pages of schematics, this does require that you actually say what the heat dissipation is for each of the components you're going to use. So if we have a look at this overload here, we're going to have a look at the component, click on DB to actually display the parts information, and we can see in there that we've got the part number, and on the right hand side there is a field, and this is essential that you put this for any component that gives off heat, that you put in there the value in watts as to how much heat it actually can give off maximum rating. So this is usually supplied by the manufacturers, and in our C-Web catalogue this information is being put in there as we speak. So all this information is put in there. What we then do is we create an extra page. We put a description, perhaps saying that this is for thermal dissipation, and we open up a template. So we go to the open, choose page template, and we can choose a template that's already in there, and this is supplied with C Electrical V8R1 panel thermal dissipation, and it's with the placing types. It's an empty page, so I can say yes to this, and we can see the actual template in there. So this shows the actual placing types on the right, and a series of attributes which are going to get filled in by the actual calculation that we run. So this is the page in the schematic. I can then go to the commands, and I look down the list of commands, and there is one there for module cabinet thermal calculation. So we go into there, double click to run the command. Now I've got one already in there. I'm going to actually just delete that for now and add a new one. So let's just put it as being example, and the method is 60890. Okay, and then that's part of the validation IEC, and that's the 61439. So the temperature range you can also put in there that you're going to put this for, depending on where it's going to be positioned. So I'll click on OK, and I'll go to next. Next, you're showing a list of the components with their part numbers and any functional descriptions you put in the project, followed by the actual power consumption that you put in there. Now if these haven't been put in, you can put these in later on. You can also filter, so if you've got different locations, perhaps multiple panels in the same project, you can filter this. You can then go to next, and this is where the main calculation is done. We've got a series of characteristics, parameters that we can set up on the left hand side, starting with the actual panel, the enclosure we're going to use. On the top right, I'm going to click on search, and I'm going to go down and say this is a particular manufacturer. I'm going to go to Rittal, enclosures, and I'm going to say that this is a 1000 by 1200. So I click on, actually notice at this point that we also have a material for the calculation here. So this could be painted steel or plastic or various different materials depending on the heat dissipation that we're going to have on it. We've also got the physical size on here, so it can work out the actual size of the panel. So we click OK. We've got those parameters. We can now say how it's going to be installed, so its position, and we've got the enclosure placing types here. So as soon as I click on, for instance, against a wall, it doesn't have anything placed on top of it, but it's just going to be placed against the wall on its own. So I'm then going to click on OK, and that's type D. I can then go to the temperature ranges that I can expect. So within the panel itself, I want there to be a minimum of say 3 degrees and a maximum of 60 is okay. That's inside the enclosure. Now I'm going to place this actually inside a building perhaps, so the minimum of maybe 5 degrees and a maximum of say 35 degrees. So we'll put this around sort of UK temperatures. A working coefficient there can be set up. So rather than working at 100%, we'll assume it's about 70 or 80%. So I'll put 80% working coefficiency. We can then put the power dissipation, and any equipment that's not got a power dissipation, it would actually list in there. I haven't got any in here, but you could then set them individually. The buzz bar we do have to set individually. So I'm going to say that this is set giving off maybe 120 watts. But you do have to put your own value in there for what the buzz bar power dissipation is. And then finally, with those values, we can check the results, and we can see the panel information. As we scroll down, we've got the minimum and maximum temperatures. We've then got a situation here where we don't need a cooling system and we don't need a heater. So we could click on finish, and we'll see that that information is then put in there. That's verified, and we can ship that panel out. Now if the parameters change, we could go back into the calculation, go to next, next again, and at this point we could say for the temperature range perhaps we need it to be slightly different. Perhaps outside it could go down to -10, and we want the minimum side the panel to be 10, and perhaps the maximum outside could go up to maybe 60 degrees. It could get pretty hot outside, but we want the temperature within the panel to be a bit lower than that, maybe 55. So now if we go down to the results, scroll down the list, we can see that both a cooling solution of 284 watts is necessary, and it gives you possible airflow that's required, and a heater is required of 302 watts. So slightly different there. We can click on finish, and again we can see those temperature coefficients, or the temperature parameters that we have to operate within, the usage coefficient, and the total calculation there for heating and cooling. So a very useful function which allows you to work out thermal dissipation within a panel.